Hello friends, today I'm going to solve LeetCode problem number 540, single element in a sorted array. So in this problem we are given a sorted array which consists of only integers, and each element appears exactly twice except one element which appears only once. Now in this problem we need to return the single element that appears only once, and this solution should be solved in O of log n time and O of 1 space. Now how can we solve this problem? So there are two hints that's given to us in this problem to approach the solution to the problem. One is that the array is sorted, and the next is that we should solve it in O of log n. And what algorithm could we used to solve a problem in O of log n? That would be binary search, and binary search can only be applied to sorted array. So we are going to use binary search to solve this problem. Now let's look at this example on how we could approach this problem. So let's just try to use brute force solution. And brute force solution, we start from index 0. All right, let me put indices to this 2 3, and this is at index 4. Okay, so we start at index 0, and then we check is index 0 value equals to the value at index 1? No, it's not, right? Since it is not equal, we return the value at our index 0. Now let's suppose we had something like 1 1 2 and 3 3. All right, so we start it in this index 0 and we compare with index 1. Since both of these values are equal, so now we increment the value by 2. So we increment our index I by 2, so now it points at index 2, and now we compare the value at index 2 with value at index 2 plus 1. And since these two values are not equal, so now we return this value at index 2. So that's our answer. Now to solve this problem, that would be O of n time complexity, and we need to solve it in O of log n, right? So what are we going to do is we are going to see now the binary search algorithm to solve this problem. Okay, so let's look at the binary search problem. So what we do is in binary search, we take the left in and the right pointer. So left pointer points towards the 0th index, the right pointer points to the index at the very end, that is the last index, which is 4. And now we calculate our mid value. Mid would be equals to left plus right divided by 2. So left plus right divide by 2, and this should be the integer value, that is we will take the floor value. So now our mid is at index 2. Okay, so this is index 2. Now this is our mid value here, so this becomes our mid. Now let's just first for instance, let's look at what would an array with all the elements appearing twice look like. So if it were all would appear twice, it would look something like this. That is 0 and 1 would be same, 2 and 3 would be same, and 4 and 5 would be same. Now we are at index 2. So 2 should be equals to value at index 3, right? So what we do is we check the value at index 2 with value at index 3. It's not equal. Since it is not equal, that would mean that our array is missing a value before we reach index m, somewhere before this index. So basically we will shift our window that is now pointing to from index 0 to 4. Our window would now become equals to only this value. So now our right pointer shifts to mid value, and our mid value gets updated, and our new mid value is now equals to Okay, so this becomes our right pointer and this becomes our new mid value. Now our mid value as index 1, right? So what should we compare at index 1? Index 1 should match with value at index 0. So now we look at index 1 and we try to match it with the value at index 0, but it's not equal. It should be equal, but it's not. Since it is not equal, we would again shift our right pointer to our mid value. So now our right pointer is shifted to our mid value, and again our mid value is updated. So now our mid value becomes equals to the index 0. So now we have our new mid value and new right pointer. So now at mid value index 0, we need to compare with index 1, right? So once we compare index 0 with index 1, we see that these two values are not equal. Since these two values are not equal, our right is now again shifted to mid value. So now our right becomes the value at mid, points to the index at mid, and our mid is also the same. So now since our mid, left and right are equal, basically we are only going to check if the mid and if right and left pointer point to the same index. If right is equals to left, then we are going to break out of loop. So we are only going to because we found our solution, right? Our solution is that on index value 1 at index 0 only occurs once. So this is our solution. So we are only going to loop while left is less than right. And how do we traverse? So basically we are traversing. So we look at the index. If we are we're at index 2, that is if it was an even index, if mid was equals to even, mid was equals to even, and even, we check the value of even with its next value, right? And the value nums, let me represent it with n. So value at m is not equals to value at index m plus 1. So in this case we would shift right to our mid position. Okay, so right will be equals to mid value. And also once we were at index 1, in case of m equals to odd, so when m is equals to odd, and so while we were at index 1, that was an odd index, right? In case of odd index, what do we need to compare? We need to compare it with the element before it, right? It should be equal to the element before it. So if the element before it, if the index value at index m and the value at index m minus 1 are not equal, that is also when we perform this operation, that is we shift towards the left. In any other cases else, we shift towards our right, that is we shift our left to mid plus 1. So we will do mid plus 1. Why? Let's look at this example here. Why are we doing mid plus 1? So in this case we are here at index 0, index 4, and this would be index 2, which is our mid. So this is left, this is right, and this is our mid. And now while we are at even index, right? So we are at even index, and value at mid should, if it's not equals to mid plus 1, so value of mid and mid plus 1, these are equal, right? Since this is equal to, we are not going to perform this operation. Basically these are equal means everything that occurs, every element that is coming before this, every has two values. So only elements that would occur after this only would have one value, right? So that's why we are shifting towards the left. So we shift towards the left, that is we take now these two values, and then we now our left becomes equals to this index, and our right is this, and our mid is also pointing to the left pointer. So now in this case the value of mid is odd, and we check it, we compare it with m-1, and while we compare it with m-1, that is at index 2, both of them are again equal. So now we go towards the left, so we move towards left again, and now we found left is equals to right, and then we break our out of loop, and our value, our solution would be at index r. So that would be our solution. Now let's solve our problem. So we are going to use this algorithm to solve our problem. So what are we going to need is left index, right index, and the mid value. Okay, so let's define our variables. Left is starting from 0, right would be in the last index, length -1, and the mid. And we are going to perform the evaluation while left is less than right. All right, and now we are going to calculate our mid value. That would be the floor value of left plus right divided by 2. And now if this condition is true, then what are we going to do is we are going to shift towards the left, that is right would be equals to mid, else our left would be equals to mid plus 1. Now what is this if condition? Okay, so let's just look here. If mid is even, so how would we know that mid is even? Well, basically the modulo operation, right? If the modulo by 2 is equals to 0, that would mean that mid is even, and the value at m is not equals to value at m plus 1. Okay, so we are going to check if mid modulo of 2 equals to 0, and value at index m is not equals to value at index m plus 1, and or if this condition, or if mid is odd and value at index m is not equals to value at index m-1. So or mid modulo of 2 equals to 1 and value at index m is not equals to value at index m-1, that is when we are going to do this. So finally our value will be stored at index pointed by r. So we are going to return, okay, retur and return the value at index r. Now let's run our code. Okay, let's submit it. Great, so we solved our problem in O of log n time and O of 1 space complexity.